Hello and welcome to AP Computer Science. My name is John Maxwell. Some of you have asked for a review of the number 4, chapter 8 problem, both A and B, so we're going to start off by explaining that. The problem asks to take, as in line 4, a string which has slashes and initially in part A return a string that has the slashes replaced with a dash, and also to put it in date month format. So, looking at part A and using the substring method, what we do is we notice that the day 19 in line 4 begins at index 3 and ends at index 4. So using the substring method beginning at index 3 and ending at 1 less than the end index of 5, we are able to capture the day portion of the string. We use concatenation to add a dash, and then we find the month portion, which is in index 0 through 1. However, because it takes 1 less than the index, it starts at 0 and includes index 1, but not 2. Using concatenation, we add the dash, and then finally, from position 6, where the year begins, we use the other substring method that takes from the beginning index until the end of the string, again with the plus sign, returning date string as required by the method signature public static string returned to an output statement. So running it, you can see that it actually has 1912 2008. Now, that's not the format we use generally in the United States, but it is a format used in other countries, which is day first, month, then year. Now, part B asks to keep the date in the format that we're familiar, month, day, year, but add a leading 0 if there is not a 2-digit date or a 2-digit month. So here we have 2, 5, 2009, and let's look at part B. Part B begins by looking for the slash. Slash 1 is found at index of, and we can find that regardless of whether there's just one day in the month or the day, or there's a double digit month or day. We can use index of to look for the second slash by starting at the position where the first slash was found plus 1. We add 1 so that we're just not finding the first slash again. And then we grab the month, which is 0 to slash 1. And the end index, recall, is again always less, 1 less than that. So we won't get the slash in string MM. And then we use an if statement, which we really haven't covered in this class, but it's pretty simple. If the month is less than 2, then we add a 0 to the month if the length of it is less than 2. So if it's a single digit month, what we're going to do is add a O in front of the month and reassign it back into the string mm. We're going to use the same calculation for day, and then we're going to get the year at /2 plus 1 until the end of the string and return day, month, year. And we can see again it adds the zeros here, and that is problem number 4b. Using all the index of substring and using a little bit of a logic test, an if statement, to determine whether or not the month and the day is less than 2 characters. So we're going to shift over to something else which I want to show you, which is surprise. The Java String Mentor on Flint AI, we only have this to the mid of the month, and I set this up and here it is. I asked, how do I change the slashes to a dash in a month, day, year format? So let's see what the AI did. To change slashes to dash in a date format like month, day, year in Java, you would typically use the replace method, and many of you did in the fulfillment of the homework. Congratulations. However, since we're focusing on index of, substring, and other methods, let's explore how you'd use these. First, break it down into pseudocode. Find the positions of the slashes using index of, and then extract the month, day, and year using the substring. Concatenate them with dashes. So here's a conceptual thing, okay? And it shows how you can use them using index of and substring. Wouldn't you have liked to try that before you went and did your homework? It's available still, so hopefully I can see more sessions. By the way, I will see how you interact with it, so there's not really any privacy. How do I eliminate leading zeros in the month? Well, it's not exactly the problem, okay? What we're doing is eliminating leading zeros. So it's very similar to what we looked at. So that's what's going on with Flint AI, and the link is in the email. So also in the forum, I encourage you to look at that. All right, well, let's move on to another topic. Endorsing Flint AI. We won't be using it all year. Why not ask the AI in a guided way? So, cutting over to another problem that I do with my students, we have a find and replace, which is I'm going to search for bad and replace with good. So I have a string here, I'm a bad, bad boy, and I'm going to find the first. I'm going to send original search and replace into the find first method. And what I'm going to do is find the position of original index of. And the search is bad, so it should return the position where the first bad is located in the string. There is a flaw here. I didn't put an if statement in to check whether position is actually -1. Okay, -1 is what's returned by index of when the search parameter here is not found. I'm assuming that it's a well-formed string and I know what I'm doing, but I'm just doing that for simplicity. So the first part begins at 0, I, and ends at position. Well, recall -1. Plus replace, which is good. And then the end part is at position plus search.length. So what is position that was found? It was the position here of B in bad plus 3, which is the length of the search term. So I get the comma until the end of the string. And so when I run it, it replaces the first. I'm a good, bad boy. And if you're familiar with find and replace, you probably have used it in a word processor before. And it won't make any replacements, if index of is -1. But, other than that, this code is pretty substantially similar to what like find and replace is in a typical word processor. Now, I want to replace all. I want to get rid of bad and bad, and I want it to read, I'm a good, good boy. Okay? So, you know, it's a little bit different, but the thing is, if find first works, wouldn't I be able to just repeatedly call find first until all the changes were made? Well, let's take a look at that. Here's find all, taking the same 3 parameters, original, search, and replace. And here we have a while loop. A while loop is one that runs while the condition is true. And everything in between the curly braces is what is actually executed. Now, we're going to look at while loops and booleans and if statements coming up. So I'm giving you a preview actually of what the next 2 units are going to be. But while original.index of search is not equal to -1, recall index of returns -1 when the search term is not found in original, we just say original equal find first, original, search, and replace. And when the while loop stops executing, we return original. So find first does all the work of find all, and we're just going to change this to find all and run it. Recall, find first says I'm a good bad boy. Find all should say I'm a good good boy. And that's exactly what it does. Now, there is a drawback, okay? And as a coder, you have to always realize badminton, the national sport of the Philippines, I believe, very popular in the Philippines and in Southeast Asian countries, island countries. Quickest way to the Olympics is to become a U.S. badminton player, but prepare to get beaten. Yeah, I'm a good minton boy because there's no catch for actually finding the exact term. So the code is only so good, okay, and that's where testing comes in. I'll just change it back, and it says, yeah, I'm a good, good boy. So that's a find and replace, and it offers up a new thing, which is a while loop, which executes every statement within the braces as long as the condition is true, as long as we're not finding search in original. And so that's a pretty decent thing. We'll cut over to our last problem, which has usually appeared on the AP exam, and that is a palindrome. Okay, so a palindrome is one that's spelled exactly the same forward and backward. So common palindromes would be madame, and race car is taco cat backwards. Okay, and no, that's not the one. Race car is forward and backwards. What's taco cat? Taco cat is actually another palindrome all by itself. But we're dealing with a more complicated and more imperialistic palindrome, which is a man, a plan, a canal, Panama. Okay, which is, Consider that. We'll take half of your country, cut it down in the middle, and build a canal and own it for like 100 years. So, how exciting. But recall that the indexing is starting at 0 and going to original dot length minus 1, which is kind of important that we review the basics. We can always get the length of the string with original dot length, and minus 1 is the last index. So the first thing we want to know is, like, there's a capital P here that's not going to match up with Panama, and there's a capital A that's not going to match up with lowercase a. So what we need to do is account for that, and then use two lowercase, which is another string method that, like, you don't have to know, okay, for the AP, but know that the string library, you can search it, Java string API. Take a moment, pause the video, go look at what string methods there are. Included in there would be two lowercase that returns the lowercase version of the string. Okay, so we've eliminated all the capitals, okay, but the punctuations are still there, and so that's a problem. The first character is a capital A, and the last character is an exclamation point, and the man, a plan, a canal, Panama. So, we got to get rid of the punctuation. So here's a new concept. It's another loop. Everything between the opening set brace and the closing set brace will execute in this loop, and it's a for loop. So a for loop has a starting condition, a stopping condition, and a change condition. So I think I'll just type that. Semicolon, change. So where are we beginning? At index 0. Where are we stopping? At the last index, original dot length minus 1. How are we changing I? By 1. I plus plus adds 1 to I. So it's a new function which is char at, and returns the char, the char, the primitive data type, which can be compared with equal equal because it's a primitive data type. And there's another class called the capital C character class. All right. And there's a method in the capital C character class. It's much like the math class. Okay, math.pow, math.round, character dot something is letter or digit. It asks if a character at position I, notice the loop counter I, if the character at that position is a letter or digit. We'll add it to the end of processed, which I declared up here. We'll add that single character I to I plus 1, which is the way to extract a single character at position I, to I plus 1, which is really 1 less than I plus 1, which is really starting and ending at I. Very well. So the important concept in line 7 is you can use a for loop and the counter I in the char at method, or in the future we'll see other index collections using a for loop to access each individual characters in this case, or elements in the collection. So a string is a collection of characters. Okay, we can extract each character at a position, okay, using the char at method of the string class, one that you don't have to know for the AP exam, but like B is very handy, okay, which is the use of a for loop. So what did I do? I processed it and removed all the non-alphabetic letters. Sorry, there's a pause there. Let me run it. Okay, sure. Yeah, that's exactly what happened. A man, a plan, a canal, Panama, and that's what gets outputted here. Okay, now that I've gotten rid of all of the uppercase letters and punctuation. Okay, let's check if it's a palindrome. Well, to see if it's a palindrome, we got to reverse it. So I create a reverse and say int I equal original dot length minus 1 while I is greater than 0, I minus minus. In other words, we're using a for loop to start at the end, the last character, and decrease I minus minus by 1 until we reach the first character 0 in the 0 index position. We add that character to reverse. So what we're doing here with the for loop is processing it character by character. It's a little bit different than the forward counting loop because the forward counting loop uses char at and the backward counting loop uses substring, but both traverse from either end the string that we're examining. So skipping through, we'll return original dot equals reverse, and the answer is true. But if we put like a small thing like a man, a plan, a can, okay, all right, I just obliterated the palindrome. We changed it right here, can. False. No longer a palindrome. So a man, a plan, a canal, Panama. Notice original dot equals reverse. It is either going to be a true or a false if original dot equals first, okay? And the method specifies a return of a boolean, so it's returning a true or false and outputting that true and false as stored in ants to the screen. A very interesting problem, and you know, you're going to see various applications of palindrome in this course, not necessarily from me, but like it appears on the exam more often than not in a whole bunch of different ways. Now, I'm going to ask the class when we're running this live how you could improve this. But the answer would be I could run through this backwards and both process it and reverse it. So down, down, diggity, and reverse it. I think there's a song there, right? No, ignore me. I could do it all at once. I could get rid of the non alphabetic or digits, okay, and reverse it by using a backward counting loop. And here I could compare the first letter to the last letter and so on, the second letter to the second to last letter, and the third letter to the third to the last letter, and see if they're the same. And if they're ever not the same, the not symbol here, okay, you could return false. Okay, so that is something that could happen, okay, as well. Let me show you that whole line. Pretty complicated. The first letter I to I plus 1 dot equals the last letter minus I, the last letter minus 0 for the first time, minus 1 for the second time, minus 2, minus 3, etc. Okay, so you're just comparing two letters and stop at the middle divided by 2. These for loops get pretty handy, you know. So here we're attacking it from both ends. Whenever you can do a divide and conquer, okay, That's great. And whenever you can provide a mechanism for early exit, there's no sense of continuing the comparison if the first and the last letter is not the same. Return false. Boom, you're done. And if you ever make it all the way through, then you return true. If you get by this for loop without ever returning false, then wow, you can say, hey, it works. It's a palindrome. So I hope this was helpful. A few more examples. Reach out if you have any difficulty. Recall that we'll meet again next week. Till then, thank you very much.